Alright, in today's video we're going to be looking at section 8.2 involving what is called the law of cosines. Just like in section 8.1 where we learned about the law of sines, our goal is going to here basically be to solve triangles. Now the law of cosines can be written in various forms, but the point of it is it's really just a generalization of this idea of the Pythagorean theorem. So we know we have this thing called the Pythagorean theorem that works for right triangles. We can extend this idea using the cosine function to actually make it work for non-right triangles as well. So let's consider this triangle where we're going to call the angles alpha, beta, and gamma within this triangle. And the angles opposite, or the sides opposite of these angles, side opposite of angle alpha, we'll call that side A. The side opposite of angle beta, we'll refer to that as side B. And the side opposite of angle gamma, we'll call that side C. Okay? Now you will be given some information about the triangle, some combination of information about angles and sides, and your goal is to find the missing pieces of information. The tool we use to do that is this law of cosines, which looks like the following. It says that side A, when squared, is equal to b squared plus c squared, which looks just like the Pythagorean theorem, except that since this is not a right triangle, we correct it. And we correct it using the cosine function, and hence the name, the law of cosines. The correction is we subtract off 2 times the length of each of these two sides, b times c, times then the cosine of the angle that is opposite the side that's on the left side of the equation. That means angle alpha, opposite side A, goes into this cosine. Now you can also write this as b squared is a squared plus c squared, the Pythagorean form, minus the correction factor, which is 2, times each of these sides that appear here, times the cosine of the angle opposite side B, which is angle B. And the pattern continues. If you wanted c squared, that would be a squared plus b squared minus 2 times each of these sides, times the cosine of the angle opposite side C, which is going to be angle gamma. Okay, 3 versions of the law of cosines, all basically saying the same thing. You know one form, you know the others, because they follow the same pattern. Now, let's take a look at applying the law of cosines to solving a problem. Let's consider problem 8 from the exercises. In problem 8, you're told that angle beta is 58.7 degrees. You're told that side A has a length of 10.6 units. And you're told that side C has a length of 15.7. And the prompt says, solve the triangle for the unknown side. Well, you know 2 of the sides, A and C. The unknown side is going to be side B, so our goal is to figure out side B. So I want to use the law of cosines that was written this way. B squared is a squared plus c squared minus 2ac cosine of angle opposite B, which is the angle beta. And you'll notice that everything on the right-hand side here, the a, the c, and the beta, those are all given to us. So I can plug those in. 10.6 squared plus 15.7 squared minus 2 times 10.6 times 15.7 times the cosine of this angle, 58.7 degrees. Now it's just a matter of working out on your calculator what we have here. So 10.6 gets squared plus 15.7 gets squared. Then we subtract 2 times 10.6 times 15.7 times the cosine of 58.7 degrees. And making sure our calculator's in degree mode, we're all set to get our answer. B squared is 185.933. Now to find B, of course, you're going to take the square root So I raise that to the half power, and I get 13.635. Rounding this to the nearest tenth, which is a rule of thumb, since these were given to us in the nearest tenth, we round our answer to the nearest tenth. B is 13.6 in length. Okay. All right, let's take a look at another example. It's problem number 14. So in problem 14, we read that angle alpha is known to be 36.6 degrees. We get that given to us that side A has a length of 186.2. And we are told that side B has a length of 242.2. Again, the prompt is find the missing side. If we're told sides A and B, that means side C is the missing side. So let me write the law of cosines in the version that has C on the left. C squared is A squared plus B squared minus 2AB cosine of angle gamma. I just use this right here. Okay. Now, plugging in the information. A is 186.2 gets squared. B is 242.2 gets squared minus 2 times the A, 186.2 times the B, 242.2 times the cosine of the angle that we're given here. This was number 14. We're given angle alpha. All right. You know what? We don't know angle gamma. And so what that means is we don't know what to put in for gamma. They gave us alpha. Okay. This I cannot use the law of cosines to solve. I don't know this angle gamma to plug in. And so I'm stuck. What could I do to solve this? Okay. My goal is to find side C. Well, what you could do is you realize you're given angle alpha and side A. You could use the law of sines on this problem. Comparing that to the side angle pair for B, and you could solve for angle B. Once you know this angle B and you know angle A, you can find angle C. And once you know angle C, then you can use the law of sines to find side C. This again is known. There's side C, the unknown. You solve it. Okay? So this is not an example where you get to use the law of cosines to solve this triangle. Okay? So number 14 is an example of what the author meant when he said, if possible, solve for the unknown side. Well, it's not possible to use the law of cosines to solve that one for the unknown side. Okay? All right, let's take a look at problem number 22. In problem number 22, we're asked to solve the triangle. Okay, we are given in 22 that side B, angle B, sorry, is 88 degrees. And now the author has reverted to using Roman letters for the angles. That's fine. We can use Greek or Roman, it doesn't matter. Side A is 4.4 and side C is 5.2. So what will it mean to solve this triangle? Well, I'll have to find the missing side, side B, and then there's two missing angles. Angle A and angle C will have to be solved for. So three things to figure out. Now, the key thing that I realize that tells me that I'm going to use the law of cosines on this is simply that I do not have a side angle pair known to me. I have angle B, I don't have side B. I have side A, I don't have angle A. I have side C, I don't have angle C. When you don't have a side angle pair, that's when you use the law of cosines. So let's go ahead and solve for side B. B squared is A squared plus C squared minus 2AC cosine of angle B. A is 4.4, C is 5.2, fill those in, and angle B is 88 degrees. I solve this using my triangle to figure out what B squared is. 4.4 squared plus 5.2 squared minus 2 times 4.4 times 5.2 times the cosine of that 88 degree angle, and I get 44.80. So B is, of course, the square root of that. Raise that to the half power, and you get 6.7 when you round it to the nearest tenth, which is a reasonable rounding to do. So 6.7 is the length of B. Okay. Now we know all three sides of this triangle. I know one of the angles, I have to go after the other angles. Now what would be the easier way for me to say go about getting angle A? I could certainly use the law of cosines to do it. I could say A squared is B squared plus C squared minus 2BC cosine of angle A, and I can plug in for A 4.4, for B 6.7, for C 5.2, 6.7, 5.2 cosine of angle A, and I can solve that for angle A. Now, as I do this, I'm going to have to first subtract these terms from both sides. Then I'm going to have to divide by this. And that will give me the cosine of angle A. So let's work that out as a number here. 4.4 squared minus 6.7 squared minus 5.2 squared all gets divided by a negative 2, then by a 6.7, then by a 5.2. And so we get 0.7544. Which means angle A is the inverse cosine of 0.7544. And I get 41 degrees. Now, if I couple that with the fact that we've already found angle B, then angle C is 180 degrees minus angle B and minus angle A. So 180 degrees minus the 88 degrees and minus the 41 degrees gives me that angle C is 51 degrees, and I have completely solved the triangle. Now notice here that I hit inverse cosine to solve for angle A. You may think, well, do you have to look for a second solution just like we did with the law of sines? Well, remember what inverse cosine sees is the top half. Inverse cosine sees angles from 0 degrees to 180 degrees. Think about any of the angles within a triangle. They're all between 0 degrees and 180 degrees. In other words, flipping this 41 degrees down here to look for a second solution to this inverse cosine does you no good, because it gives you an angle of negative 41 degrees, which is not going to be an angle inside a triangle. The inverse cosine sees the entire range of values where an angle can be for any triangle. Therefore, there is no such concept as having to flip to solve using the law of cosines for a second angle. Okay? Now, that's one of the convenient things about the law of cosines. We don't have to worry about the ambiguous case where we get more than one solution arising. All right, let's take a look at problem number 26 next. In 26, they've asked us to solve the triangle where they've given us that side A has a length of 51. Whatever the units might be. Side B is a length of 25, and side C is told to be a length of 29. Okay? Notice you've given all three sides of the triangle. None of the angles are told to you. Okay? So you have to find angle A, you have to find angle B, and you have to find angle C. So think about how you'd find angle A. Well, you'd want the law of cosines that has angle A appearing in it. And that's this. Plugging in for A, B, and C. 51 squared is 25 squared plus 29 squared minus 2 times 25 times 29 times the cosine of angle A. Subtracting these two from both sides. Leaves this minus 2 times 25 times 29 times the cosine of angle A on the right, and then dividing both sides by this. Gives you the cosine of angle A. And that's what we'll work out on our calculator now. So 51 squared minus 25 squared minus 29 squared gives us the top. Did we do that right? 51 squared minus 25 squared minus 29 squared. Okay? All right. Now, divide that by negative 2, divide it by a 25, and divide it by a 29. We get negative 0.7828. Hitting inverse cosine, we get angle A is 141.5 degrees. There's our first angle. Okay. Now let's go after angle B. For angle B, you want the law of cosines that uses angle B. So think of B squared equals A squared plus C squared minus 2AC cosine of angle B. Now, if you feel more comfortable without plugging the numbers in, you can simply work with these letters. You subtract these from both sides. Then divide by the minus 2AC. And now you have a formula, basically, that you can plug into to solve for angle B. So plugging in side B, 25 squared, side A, 51 squared, side C, 29 squared, divided by a negative 2 times a 51 times a 29, and that's what the cosine of angle B is going to be. Let's work this out on the calculator. 25 squared minus 51 squared minus 29 squared. Negative 2817 now gets divided by negative 2, gets divided by 51, and gets divided by 29. So we get 0.9523, which means angle B is the inverse cosine, 0.9523. And we get 17.8 degrees. 17.8 degrees. Okay. Finally, we have to go after angle C. Now, I certainly could use the law of cosines to find angle C, just like I did to find angle A, and just like I did to find angle B. But there is a much simpler way to find angle C, and that is take 180 degrees minus the two angles you've already found. So 180 degrees minus 141.5 degrees and minus 17.8 degrees, and we get 20.7 degrees, and we're done. We have solved the triangle completely. Okay. All right. So let's try, get a little more paper. Let's try another problem here. Let's try problem number 28. Where the author says, use Heron's formula to find the area of the triangle and round to the nearest 100th. So the idea here is Heron's formula. Given the three sides of any triangle as A, B, and C, the area of the triangle is the square root of S times S minus A times S minus B times S minus C, where of course A, B, and C were the three sides you're given, and this value S is simply the sum of all three sides divided by 2. All right, in problem 28 now, we are told that the length of the three sides are 20 centimeters, 26 centimeters, and 37 centimeters. It doesn't matter which one's A, which one's B, which one's C. It makes no difference in the formula. What matters is you're going to calculate S correctly. 20 plus 26 plus 37 gets divided by 2. We'll use our calculator for that. 20 plus 26 plus 37, that's 83, gets divided by 2, gives me 41.5. Now plugging into the area formula, the S again is 41.5. S minus A is 41.5 minus 20. S minus B is 41.5 minus 26. And S minus C is going to be 41.5 minus 37. And that's what we calculate. Now, I usually find it easier when I'm doing this calculation to do the calculation in the parentheses first. So 41.5 minus 20, of course, is going to be 21.5. Then 41.5 minus the 26 comes next. That's 15.5. Then the 41.5 minus the 37 comes next. That's 4.5. Then I'll type this into the calculator and take the square root. 41.5 times 21.5 times 15.5 times 4.5. Raising that to the 1/2 power to get the square root. The area is 249.5. And that's how Heron's formula works. A very simple formula that's very, very old. Been around for thousands of years. Okay? All right. Now, let's take a look at an applications problem in number 52. In 52, scrolling down, we're told that a parallelogram has sides of length 16 units and 10 units. So a parallelogram basically looks like a rectangle that's been pushed so that the two pairs of sides are still parallel to each other, but you don't have 90-degree angles anymore. So your parallelogram may look something like this. So we've got a longer side here parallel to a longer side here, and a shorter side here parallel to a shorter side here. Okay? And we're trying to find the measure of this long diagonal here. I want the measure of this length right here to be known to me. Okay? And again, what we were told was the length of these the longer side and the shorter side are 16 and 10. So that's 10 and that's 16 as well. Okay? They also tell us that if we were to draw the shorter diagonal, that the length of that shorter diagonal is 12. So when we look at this, what we realize is we have a triangle here, 16, 12, and 10. I can solve this for any of the angles that I want within here. Okay, 16, 12, 10, I can solve for this angle, or this angle here. Okay? All right, so let's see what we would do here to try to solve this thing. Okay? I am going to be trying to find the length of this side here. Okay? If I knew this angle here, I'd be in business to do that. So why don't we say this is the angle A and figure out what that angle is. Okay? Opposite it, side A, 10 squared. Okay? No, opposite of this, let's see. We've got 10, okay, equals 16 squared plus 12 squared minus 2 times 16 times 12. Right, opposite A was the 10. Then the two others are 16 and 12 times the cosine of that angle A that I don't know. And that's what I have to solve for. Okay? So let's move everything over. 10 squared minus 16 squared minus 12 squared all gets divided by the minus 2 and the 16 and the 10, and that's going to be the cosine of angle A. And we work that out on our calculator. 10 squared minus 16 squared minus 12 squared gets divided by a negative 2, gets divided by a 16, gets divided by a 10. 0.9375. So angle A is the inverse cosine of 0.9375. Angle A is 20.4 degrees if I round to the nearest tenth. Okay, so I found this angle 20.4 degrees. Okay, now I would like to know the length of this red segment right here. Call it x. That's opposite angle 20.4 degrees, and this side of the triangle is still 16, but now consider this side here. It's half of this diagonal of 12. It's 6. And apply the law of cosines to find the length of x. That would be x squared equals 16 squared plus 6 squared minus 2 times 16 times 6 times the cosine of that angle A, 20.4 degrees. Let's work this out. 16 squared plus 6 squared minus 2 times 16 times 6 times the cosine of 20.4 degrees, and I get 112.04. So x is the square root of that, or 10.6. X is 10.6. That longer diagonal, therefore, is 2x. That's what 10 times 10 is, or 10 times 2 is 20. 0.6 makes 1.2, 21.2. There's the length of the longer diagonal on your parallelogram. Okay? All right. Let's take a look at problem number 56. In 56, we read that a regular pentagon is inscribed in a circle of radius 12 centimeters. So we start by drawing a circle. Okay, and we're going to imagine that this circle has a radius of 12 centimeters. Okay, now we want to draw a regular pentagon within this. A regular pentagon means a five-sided object where all five sides are the same length. That's what regular means when you're describing a shape, that all the sides are of the same length. All these sides are supposed to be the same length. And I know it doesn't look very good the way I drew it. I'm not very good at drawing these things. The radius is 12. So that's 12, that's 12, that's 12, that's 12, and that's 12. Okay? One other thing we know, the complete sweep around a circle is 360 degrees, and I've cut that into 1, 2, 3, 4, 5 equally sized rotations. So 360 degrees divided by 5 gives me 72 degrees. Now if I can find that length x here, that's the same as this one, the same as this one, the same as this one, and the same as this one. So the perimeter of this regular pentagon is going to be 5 times this x. How do I find that x? I use the law of cosines. X squared is 12 squared plus 12 squared minus 2 times 12 times 12 times the cosine of 72 degrees. Work that out. Okay, 12 squared is of course 144. Add that to itself, it's 288. Same as 12 times a minus 2 is a negative 288. So I get 288 minus 288 cosine 72 degrees. 288 minus 288 cosine 72 degrees. I get 199.00 basically. So raising that to the 1/2 power, I get 14.1 for x. So the perimeter, add this 14.15 times, and we get 70.5 as the perimeter. And we're done with the problem. All right, one last problem I'd like us to consider today. Problem number 64, this navigation problem. Let me go ahead and start on a fresh page. I'll flip this over. All right, number 64. In problem 64, we read the following. An airplane flies 220 miles with a heading of 40 degrees. Okay? Now the way a heading works is you look on a compass. You've got north, south, east, and west. Heading is the measure that you get when you put yourself in the position pointing north and then rotate yourself clockwise a certain number of degrees. So a heading of 40 degrees would be point north and rotate clockwise 40 degrees. It will look like this. 40 degrees for a length of 220 miles. And we end up here. Okay? Now, they tell us then, from this position, we're going to fly 180 miles with a heading of 170 degrees. So again, look at your compass. There's north. Point yourself north and rotate 170 degrees clockwise. That's almost all the way down. Not quite, but almost, right? And then you fly 180 miles is what they tell us. And you end up here. And the question is, how far are you from where you started? And what is your heading? Well, let's first figure out how far we are, okay? The way I'm going to do that is I realize the following. The north-south line here and the north-south line here, those are two parallel lines. And if I cross them with a straight line, I know that the angle here is the same as the angle here. That means this angle in here is the same as this 40 degrees. Furthermore, I know that this was 170 degrees to get here. Another 10 degrees would have got me down to the south line. So there's 40 degrees here, 10 degrees here, for a total of 50 degrees right here. All right. So now I know this side, I know this angle, and I know this side. Let's apply the law of cosines to find x. X squared is 220 squared plus 180 squared minus 2 times 220 times 180 times the cosine of that angle, 50 degrees. 220 squared plus 180 squared minus 2 times 220 times 180 times the cosine of 50 degrees gives me 29891.2. So x, when I take the square root, raising that to the 0.5 power, 172.9. Okay? That's how far it is from our starting point to this position, 172.9 miles. Okay? All right, now once I have found that 172.9 miles, or if you want to round it to 173 miles, that's perfectly fine as well. Now we have to find the angle here. So think about this. You know all three sides of this triangle. You want to find this angle. Okay? So let's make this the side opposite the angle we're after. 180 squared equals 220 squared plus 173 squared minus 2 times 220 times 173 times the cosine of this unknown angle here. I'll just call it angle A. Subtracting these two, and dividing by this will be the cosine of that angle that I'm after. Okay, let's work that out. 180 squared minus 220 squared minus 173 squared gives me the numerator. I divide that by a -2. I then divide by a 220, and then I divide by the 173, and I get 0.6034. So A is the inverse cosine, 0.6034. A is the angle 52.9 degrees. Okay. Now I use that angle to help me figure out my heading here. We already said go 40 degrees to get here. Now we're being, from the diagram we can see another 52.9 degrees gets us here. If you want to round that to 53 degrees, that's good enough. 40 degrees plus 53 degrees here gives me the heading of 93 degrees. And we're done with the problem. Okay, so that's it for section 8.2 on the law of cosines. Please give those homework exercises a try. This is a type of work that you may find is pretty straightforward for you once you get the hang of it. This is probably not as challenging as some of the other stuff we do with trigonometry involving general identities. So this is your opportunity when you're dealing with the law of cosines and with the law of sines to get some good solid points on any work you're doing. Okay? All right, good luck, and as always, let me know if you have any questions or concerns so that I may address them.